Have you ever noticed how the full moon looks bigger when it's near the horizon than when it's high overhead? If so, you're not alone. People have wondered about this strange effect since ancient times, and surprisingly, we still don't have a great explanation, but that's not for lack of trying. Some of the greatest minds in history, Aristotle, Ptolemy, Da Vinci, Descartes, have all wrestled with this problem and failed to generate an adequate explanation. One of the first ideas suggested was that the image of the moon in the sky really is bigger near the horizon. Perhaps the Earth's atmosphere acts like a giant lens, magnifying the moon as it rises and sets. But this explanation doesn't cut it. If anything, the refraction of the atmosphere would make the moon look slightly smaller. Plus, if you actually measure the size of the visible moon at different positions, it doesn't change at all. But then why does it still seem bigger when it's rising? This must be some kind of optical illusion. The question is, which one? One explanation is the Ebbinghaus illusion, where two identical objects look different because of the relative size of the objects they're surrounded by. Here, the two center circles are actually the same size. Maybe the moon looks bigger near the horizon because it's next to tiny trees, houses, and towers in the distance. But when the moon is higher up, it's surrounded by the vast darkness of the night sky and looks tiny by comparison. Another possibility is the famous Ponzo illusion. If you've ever tried to draw in perspective, you know that the closer something is to the horizon, the smaller you should draw it. Our brain compensates automatically for this by perceiving objects near the horizon as larger than they actually appear. The two yellow lines in this drawing are the same size, but the upper one seems bigger because we interpret it as receding farther into the horizon. So between Ponzo and Ebbinghaus, it seems like we've solved the mystery of the moon illusion,